Hello, welcome to Chapter 8, Homework Questions 105 to 111. Question 105. A regular hexagon with side length 4 has the same area as a square. What is the length of the side of this square? Explain how you know. Alright, so let's start with a regular hexagon with a side length of 4. So let's go ahead and calculate the area of the hexagon with a side length of 4. So we'll start here, focus on this triangle with a side length of 4. I'm just going to make that triangle a little bit larger so we can see things a little bit clearer. So there's that. We know this side length is 4. It is a hexagon, so in terms of the center part there, it's 360. We're going to break it up into 6 different parts, so that makes this angle up here 60, which means this is an equilateral triangle. So all of these lengths are actually 4. So to find the area, we need the height of the triangle. And since it is a 60 and 90 degree angle, this angle right here would be 30 degrees. So we've got a 30, 60, 90. This length is equal to this length, so both of these are 2. And so if we use our special right triangle, we know that the leg across from 60 degrees, the long leg, is the short leg times the square root of 3. So 2 square roots of 3 would be the height of that triangle. So we can find the area of this triangle by taking 1/2 times the base, which is 4, and then the height is 2 square roots of 3. So the area of that triangle would be 4 square roots of 3. And I'm going to leave it like that because that's just the area of that triangle. How many triangles do I have in a hexagon? That would be a total of 6. So I'm going to take 6 times 4 square roots of 3, and that will give me the area of the hexagon is equal to 24 square root of 3. Alright, so that's the area of the hexagon. Now it says that it has the same area as a square. So here's a square. We're going to say the area of this square is 24 square roots of 3. Think about it this way if it helps. Let's just make the number a little bit nicer. What if the area was 36? How would you find the side lengths? Well, remember, these are both going to be the same. So what times what gives you 36? And that would be 6. So how do we do that? We can take the square root of it. So to find these side lengths here, we're going to take the square root of the area, which is 24 square roots of 3. Now, what does that equal? That, go ahead and plug in the calculator so we can get approximately what that value is. So once again, square root of 24 square root of 3 is approximately 6.45. And so make sure, because it is asking for the length of the side of the square, that you write that out. So the side of the square is about or approximately 6.45 units. Question 106. Use what you know about similar figures to complete the following tasks. Part A. Find the area and the perimeter of the trapezoid below, or in this case off to the right. So we can find the area is 1/2 times the height, which is 4, times the sum of the bases, 8 plus 13. So the area would be equal to 42. And it doesn't have any units on there, so we got units squared. The perimeter is the distance around, so we can just add those up. 5 plus 13. And then we got to figure out this side, so we'll figure that out in a little bit. So not sure what that is yet, plus 8. So we got to look at this. So let's see here. Let's break this up into a right triangle. We know since this is 13 all the way across, that this side right here is 8. So what does it make this length right here on this triangle? Well, this is a Pythagorean triple, so it's a 3, 4, 5 triangle. So there's that length. So if this is 3 and this is 8, that's a total of 11, which means this length right here has to be 2. Don't assume that it's an isosceles trapezoid. It doesn't say anything about that. So that will give you a total distance. 3 plus 8 plus 2 would give us the total distance of 13. So now if this is a 2 and we know this is a 4, then we can find x by doing Pythagorean theorem. 2 squared plus 4 squared is equal to x squared. So that's 4 plus 16. And then that's going to be the square root of 20. And then you can plug that into your calculator to get approximately what that is. So x would be approximately the square root of 20, which will be 4 something, 4.47. And so now we can put 4.47 here, and now go ahead and add those up. And we get a perimeter, once again, approximately, of 30.47 units. So that's part A. Part B, find the area in the perimeter of a trapezoid that is similar to this one, but has been reduced by a linear scale factor of 1/3. So it's been reduced by a scale factor of 1/3. So your perimeter, well, I guess I should do area since I have it first. The area of the last one was 42, and it's similar, and once again, by a scale factor of 1/3. So the area, in terms of the similarity in the area, remember it's squared by so the linear scale factor is, let me write this down. So I'm just going to say LSR, linear scale, or LSF, which is actually R, but R is equal to 1/3. So when you're looking at the area, it's R squared. So in this case, it would be 1/9. So we need to take 1/9 of, so the area of the new one will be 42 times 1/9. And that will give you, it's 4.7 if you want to round it, but it is 0.6 repeating, so that is the fraction 2/3. So we'll do 4 2/3 so we can get the exact answer. 4 2/3 units squared. So that's what the area would be. Now, on the perimeter side of things, the linear scale factor is still 1/3, and the perimeter ratio is the same one. So R is equal to 1/3, and so therefore the, I'll just put perimeter ratio is also equal to 1/3. So we just need to take a third, so your perimeter was 30.47 approximately, which means that the perimeter is going to be about 1/3 of that as well. And so we'll get a perimeter of approximately 10.16 units. So there's your new perimeter. Here is your new, I guess this is actually your new area for that. Question 107, an exterior angle of a regular polygon measures 18 degrees. How many sides does a polygon have? So remember, we have multiple entry points onto this one as to how we want to approach this, but it does give us the exterior angle of the polygon, so therefore we can find the interior angle pretty easily. But also, if you remember that exterior angles are going to add up to 360 degrees for a regular polygon, so we can then divide that by 18 degrees, and that will tell us how many basically, triangles you're going to have in there, which also equates to the number of sides. And therefore, on this one, that means you're going to have a 20-sided polygon. So 20 sides for that. So that answers the first part. B, if the length of a side of the polygon is 2 units, what is the area of the polygon? So once again, different ways that you can look at this, but we're going to break it up into this triangle, this isosceles triangle. The length of the side of the polygon is 2, and then we can split this up into our 90, or right triangle there. We know this length is 1 and this length is 1, and we got to look at the angle measure. So we know that the angle, we know that the exterior angle is 18 degrees, so we could find the interior angle. We could also take 360, just like we did, and divide that by 20, which tells us it's 18 degrees, which once again we already had that. But then we can break these up into 9 degrees. So each one of these would be 9 degrees, which then means that this angle right here, if you want it, you don't need it, but would be 81 degrees. So we have a couple options. We don't have a special right triangle here, so we are going to have to use some of our trig. So let's just use the 81 degrees, and let's see, we have the adjacent side and we need the height, so we will go with tangent. So we're going to do tangent of 81 degrees is equal to opposite, which we'll just call this h, over the adjacent, and that is the value of 1. So on this one, h is equal to whatever tangent of 81 degrees is. So just make sure your calculator is in degrees, and you're going to get the height is approximately, we'll go 6.3 units. So now we have the height, we have the base, so we should be able to find the area of this triangle. So that's 1/2 times the base times the height, which we found approximately to be 6.3. So therefore the area of the triangle will be approximately 6.3. Half of 2 is 1. 1 times 6.3 is 6.3. How many total triangles are we going to have in there? Well, there's 20 sides, so there's going to be 20 triangles. Whoops. So we'll take 20 times 6.3, and that means that the area of the 20-sided figure will be approximately 126 units squared. And so that's how you can go through and find the area of a polygon, just like we did with any of the polygons. Question 108, find the missing angles in each problem below using the geometric relationship shown in the diagram below. Be sure to write down the conjecture that justifies your calculation. Remember that each part is a separate problem. All right, so starting with part A, D is equal to 110 degrees. There's that one. K is 5x minus 20 degrees. Write an equation and solve for x. So these two angles, notice that we are dealing with parallel lines here. So these would be alternate interior angles, which means they should be congruent, which means their measures are the same. So we will set up our equation. 5x minus 20, wrote the wrong number, degrees is equal to 110 degrees. And this is because of alternate interior angles. All right, and so we add 20. It gives us 130, divide by 5. And x is equal to 26. So we know x is equal to 26. Once again, because the lines are parallel, alternate interior angles are congruent or equal. All right, part B. So let me erase this because we're going to start a new problem now. So new information. If B is equal to 4x minus 11 degrees, n is equal to n is equal to x plus 26 degrees. Write an equation and solve for x. Then find the measure of angle n. So an added piece right here we got to make sure we remember to do. So not only are we going to solve for x, but also find the angle measure. So we can look at this and kind of just start marking things. Angle n is congruent to angle k because those are vertical angles. We also know k is congruent to angle d because they're alternate interior angles. And so therefore, these two angles form a straight angle, so we know that they are supplementary. So we are going to add the two angles up and set them equal to 180 degrees. So 4x minus 11 degrees plus x plus 26 degrees is equal to 180 degrees. That'll be 5x plus 15 degrees. Just combining my like terms, subtract 15, 165 degrees, and then divide by 5. X is equal to 33. Now, that's the value of x. To find the measure of angle n, we just plug it in. 33 plus 26 will give you 59 degrees. So now we also know that the measure of angle n is equal to 59 degrees. So, like I said, make sure you are answering both questions. And we did use a couple different things. We used vertical angles. We also potentially used alternate interior angles. And these are both, congruent or equal in measure. And then we ended up using the straight angle. And straight angles are supplementary. So, combination of those things. Question 109. Ronaldo has a stack of blocks on his desk, as shown below. If his stack is 2 blocks wide, 2 blocks long, and 2 blocks tall, how many blocks are in the stack? Well, you can see you have 1, 2, 3, 4, and then on the back side you're going to have 1, 2, 3, and then you can't see that fourth one, but it's behind this one right here. So that would be a total of 8 blocks. What if his stack instead is 3 blocks wide, 3 blocks long, and 2 blocks deep, or 2 blocks tall, I guess? How many blocks are in this stack? So you're going to be adding an additional block this way, right? So it'll add that, and then we'll go over here and combine that. So you're going to go 3 this way, It's still only 2 wide and 2 tall, so we still have to add another part to that. So, think about adding an additional block on the top here. I guess it doesn't really matter which way you label it, but that's what you would be looking at. Not very good at drawing that, apparently. So you have 3, 3, and 2. So if you add that up, you're going to have a total of 9 in the front. And then you have 2 sets of them, so 9 plus 9 would give you 18 blocks. What if a stack contains 99 blocks? Is 3 blocks tall, X blocks long, and Y blocks wide? What could X and Y be? So what you hopefully have noticed here is this really is a volume problem. So 2 times 2 times 2 is going to give you those 8 blocks. In this case, 3 times 3 times 2 will get you those 18. So if a stack is 99 blocks, and we know 3 blocks tall, then we need some other numbers that multiply to give you the 99. So if we divide by 3, we have a couple of different options here. What 2 numbers multiply to give you 33? You could have some different combinations. We could say x is 1, and that means y would be equal to 33. We could say x is 3, and then that means y is equal to 11. And those are really the numbers that go into it, so I guess you could also switch these around and say, okay, well, x is 11, which means y is equal to 3, and then x is 33, which means y is equal to 1. So these would really be the different combinations that you could have for that stack of blocks. Question 110. Krista is trying to solve for x in the triangle below, or to the right. What equation would Krista write? So let's see, we're looking to solve for x, we got a right triangle, so we can use our trig ratios. X represents the adjacent side. 7 represents the hypotenuse. So for part A, we could use the trig ratio for cosine. Cosine of 58.5 degrees is equal to the adjacent side, x, over the hypotenuse of 7. So that would be the equation. B, Krista does not have a calculator, but she remembered something funny her friend Juanisha told her. Juanisha's favorite sine ratio is sine of 31.5, and it is approximately 0.522. Because 5 divided by 22 is Juanisha's birthday. Without a calculator, using Juanisha's favorite ratio to solve your equation from part A. Alright, so what we might recognize here is the 31.5 actually represents the other angle measure on this one. So instead of using the 58.5, what if we use the 31.5? So now x would represent the opposite side, so that would give us sine of 31.5 degrees is equal to opposite over hypotenuse. But since we know what Juanisha's favorite ratio is, we can replace that with 0.522 is equal to x over 7, and then multiply that by 7, and we should be able to get an approximation for what x is. So 0.522 times 7 is approximately 3.654. So we were able to use Juanisha's favorite number, or at least favorite sine ratio, to be able to figure out what x is without the calculator. Question 111, multiple choice. Which type of quadrilateral does not necessarily have diagonals that bisect each other? So we're looking at a square, a rectangle, rhombus, and we have a trapezoid here. So once again, which type of quadrilateral below does not necessarily have diagonals that bisect each other? So you might need to go back to your math notes to take a look at some of these if you don't remember. Or sometimes if you can just picture what the shape is going to look like, maybe you can tell, okay, will those bisect each other? And with a square they do, so a square is fine. Same thing with a rectangle. And we're not talking about the angles, we're talking about the lines themselves. So do these bisect each other? Once again, that is true. And with a rhombus, remember, really just kind of a tilt to the square. And even though that those are not the same, they do bisect here and here. So they do bisect each other. And a trapezoid, kind of vague. It's not an isosceles, not any specific type of trapezoid. But when you do a trapezoid, and I'm just going to draw a right trapezoid so you can see, all right, those are not going to bisect each other. Look at this one compared to this one up here. So D would be the answer, where the diagonals that bisect each other, that they don't necessarily bisect each other.